Okay, this is the video for number 14 on page 296. In our last video we went over numbers 5 and 11, both of which were rate times time or distance rate time issues, and we came up with the following formulas that we just kept off to the side so that we could remember that if the book gives us one of these, if the book gives us the rate or the distance or the time, we can figure out the rest, because the book will usually give us a difference in rate or a difference in distance or a difference in time, and that will allow us to generate the equation. So let's look at number 14. Number 14 says the rate of a stream is 4 kilometers per hour. Scott paddles downstream 9 kilometers and back upstream where he started, and it took 10 hours totaling. What's the rate of paddling in still water? So if we can find out his rate upstream or his rate downstream, we can adjust it by 4 accordingly, and we can figure out his rate in still water. That's the first thing to understand. The second thing to understand is, what is the difference that they're telling us? Because we want to be able to say in one circumstance a variable is a certain number and subtract it and we get the difference. So that wasn't very well explained. Anyways, are they giving us a difference in time? No, they give us the total time. Are they giving us a difference in distance? No, they tell us it's 9 kilometers. They're giving us a difference in rate. They're telling us that the rate of the stream is 4 kilometers an hour. So as he travels upstream, he travels against the current that's fighting him at 4 kilometers per hour, and then when he goes downstream, he's got the current at his back and helping him by 4 kilometers an hour. So the difference in the rate between his two directions is actually going to be 8 kilometers per hour. Make sure you understand that before we proceed. 8 kilometers per hour is the difference in the rates. So when we look at our little toolkit here, it's the rate that's different. We know that the rate is going to be 8 kilometers different between going up and going down. We also know that it's going to take, his speed is going to be higher, or the rate's going to be higher downstream than it is upstream. So the rate downstream is a bigger number. So we can say that the rate downstream minus the rate upstream is going to equal 8. And so we can now translate that into distance over time, because we know rate equals distance over time. So difference over the time downstream minus the distance over the time upstream equals 8. Now we don't know time downstream and time upstream, but we do know that when we add them together we get 10 hours. So let's define one of these variables as t, so we don't have this little td and tu business. So let me set up this equation again. And we know that the distance is 9 kilometers, so I'm going to put the 9s in. And I'm going to say let t, we'll just call this t now, equal time downstream. And when I solve for t, I'm not going to have the equation or the problem solved yet, because knowing t, or the time downstream, will just give us how long he spent doing it, and then we have to calculate the rate downstream and subtract 4 to figure out what his still water rate is, because remember, they're asking what is Scott's rate in paddling in still water. So this is like a 2 or 3 step problem. So the time downstream, which is going to be shorter, time downstream, and the time upstream is whatever is left of the 10 hours after you take out the time you spent going downstream, so 10 minus t. So with this equation we solve for t, and once we've solved for t, which is the time downstream was the time it took him to go 9 kilometers an hour with the rate of the stream at his back. So whatever we solve for t, we have to subtract the 4, because that was the extra kick he got from the stream going downstream, and that's his still water rate.